Hello folks, we come to the miscellaneous exercise of this chapter and let us see now how to proceed with the miscellaneous exercise. A little higher end but very good applications which helps you to understand why we have been doing all these shapes, how it is used practically in day-to-day life. You have problems based on that. So though it is little higher end, you have to interpret it properly, understand the shape, get the data, and then solving becomes easier. So we are taking the first problem which says that it is if a parabolic reflector is 20 centimeters in diameter and 5 centimeter deep, find its focus. So parabolic reflector, directly they have told us that it's a reflector which is in the shape of a parabola. So we have drawn it. A parabolic reflector is like this, something is coming and it is reflecting. Okay, it has got a reflecting surface. So that's the meaning. Now this parabolic reflector, they say it has got diameter as 20 centimeter and it's 5 centimeter deep. So diameter as 20 centimeter obviously means that this entire length is 20. This full thing is 20. Always parabola, it's symmetric about the y-axis. So that way it is clear that this will be 10 and this part will be 10. That is also clear. Right, so that is about the diameter and that is how the things are spread. Then they say that it is 5 centimeters deep. So suppose if the parabolic reflector is still here, then this is 5 centimeter. This much is being given to us. With the help of this, they ask us to find out the focus of this parabola. That means you have to find A. So somewhere you have to find maybe the equation of the parabola, and from there probably we'll have to work it out. Probably it is that way. So for our convenience, let's call this point as O, let this point be A, let this extreme point be B, let this point be C, for our convenience. Maybe that will help us to solve this, and this is your parabolic reflector. So let's introduce the parabolic reflector, see what all things are given to us, and let's see how to work. We know that this parabola is of type 1, y squared equal to 4ax. We have taken it for our convenience. Obviously reflector has to be like this because it is reflecting somewhere. It cannot be up or down that way. Either it is of this side or of this side. That type of parabola. For convenience we have taken it like this, right? So let the reflector be as shown in the figure. Let the reflector be as shown in the figure. As shown in the figure. Here, AB is the diameter. AB is the diameter. Then OC is perpendicular to AB. Okay, and OC indicates the depth. Indicates the depth. So that's how we are introducing the problem, right? And because of all this, we are able to, because all these things are given to us, we are able to interpret all this, that numeric data. It has been told to us that the diameter is 20 and AB is 20, which means that AC, which is equal to CB, and that is further AB by 2, becomes 10. Also, because you know that OC is the depth, that is 5 centimeters. So many things are there. Now, the equation of this parabola, is y squared equal to 4ax. Point A is made up of this coordinate and this coordinate. So it's clear that point A is 5, 10. Yeah. So we can write from the given, it is clear that A with coordinates 5, 10 belongs to the parabola. So it satisfies. So therefore y squared equal to 4ax has 5, 10 belonging to the parabola. So it satisfies. Satisfies means x and y. So 10 into 10 equal to 4 into a into 5. like that, you will get the A value as 10 into 10 by 4 into 5. So 10, 2 2s are 2 5s are, then 2 5s are. Like that, A will come as 5. That's what they have asked us. What is the focus, isn't it? What's the focus? So focus is this. Therefore, the required focus is 5 centimeter, can we tell? If we want. Focus is actually coordinate, isn't it? 5, 0. What do they ask us? Coordinate. So 5, 0. Sorry, you cannot say required focus is 5. You can tell it as 5, 0. It's a coordinate. Right. A, 0 is a equation. That's our first problem. Very interesting. Then we have the second one. Let's see the second one also. It's an arch. An arch is in the form of a parabola. So you've got an arch which is parabolic. Oh, it's very difficult. A parabolic arch, in order to get it with that curve, I don't know, the civil engineer and the architect and the builders, I don't know, they'll have to rock their heads. Right, anyhow, an arch is in the form of a parabola with its axis vertical. So the arch is like this, not that the arch is sleeping, right? The arch is vertical. The arch is 10 meters high, like what we got here. It's 10 meters high and 5 meters wide at the base, like this. And how wide it is at 2 meters from the vertex of the parabola. No problem. Let's see what they try to tell us. They are telling that there is an arch with its axis vertical. I hate the shivering lines. When the lines shiver, it doesn't look nice. So let's have straight lines. The arch has got axis vertical that itself decides. You cannot have an arch like that. You don't have it like that. So obviously, oh God, this is what I was dreading. How my parabola is going to come up. Those people who have a very good sense of symmetry, they can do it really well. I should confess my symmetric sense is not so good. That's why it's not coming so well. Right. So all this, whatever they have told us, let's try to put it across. Like before, let's call this as A, let's call this as B, let's call this as C. And they are telling us that there is this arch. I hope you are convinced with this arch, how it is vertical and why we have to have it like this. When the axis is vertical, either it can be like this or it can be like this. Those are the only two cases when the axis is vertical. Now you don't have arches like that, isn't it? All arches are this way. So you have to choose like this. Fine. Now, and depending on the data that is given to us, they tell us that the arch is 10 meters high. So this is 10 meters. Yes. And what else? They say that it has got a width of 5 centimeters. Yeah, 5 meters. Total width is 5 meters. At a distance of 2 meters, how wide it is at a, so suppose if there is a point D such that OD is 2 meters, then we must find what is EF. That's the question. To find EF when OD is 2 meters, that's secondary. That's the second subpart you can treat. First, we have to deal with, always when they give us a parabola, automatically, indirectly somewhere we have to find the equation, and it is that equation that is going to help us to solve whatever that we require earlier. So it's very clear to us from the drawing, it's clear to us that what kind of parabola it is. It's of type 4, x squared equal to minus 4ay. So that way you know the equation of the parabola. And like before, we try to, with the data that is given to us, let's try to get one point on the parabola, then we can substitute it, which will give you the a value. And once you get back the equation of the parabola, then you can switch over to find whatever they ask us. So probably it is going to be like this. So let's introduce. Let the arch be as shown in the figure. be as shown in the figure. And what happens here is AB is its width, yeah, and OC is its height. OD is what do they tell us? OD is the height where the width has to be found. Where the width has to be found. Has to be found. We are just introducing. So to find EF, we have made those introductions and kept. Now with whatever data that we have, and we have the data, so let's put it across and let's see. AB is 5, so AC, which is a half of it, is going to be 5 by 2, so that is done. And they give us that OC is 10. They've told us the depth is 10, so that much is there, and about 2 and all we have shown it, we have indicated it, and that as the sub part comes we'll tell. So much is there with us. Now we have to tell about the parabola. Also, the equation of this parabola is x squared equal to minus 4ay. Now we have to tell about a point belonging. This is how we have been doing. First we introduce it, then we put the values, then we get the equation, and then we put a point, right? So you should get some point, generally A or B. So B is better because here we will have little more positive things. So for B, this distance we have found out that it is 5 by 2. So the x coordinate is clear, it is 5 by 2. How about the y coordinate? Y coordinate means it should be this much distance. And this much distance, it's clear to us that it is 10, isn't it? So that is also there. So that we get it from the given. So from the given, B with coordinates 5 by 2, 10 belongs to the parabola. So it satisfies the equation of the parabola. That is, or in essence, you have x squared equal to minus 4ay, now getting converted as x, we can take it as 5 by 2 the whole squared minus 4a, and y you can take it as 10. So minus 4a you can have it on one side, because it's basically we want the equation, because we have to find that point thing, so no need to get that 4, let it be there so that our solving will be easy. And and I have to rectify myself with this coordinate that x is 5 by 2, okay, but 10 has to be minus 10 because we are on the negative y-axis, so automatically this is also going to be minus 10. So that rectification we have to do everywhere, it's minus 10. So it's 4a 5 into 5 by 2 into 2, and the 10 has to go on the other side. Minus into minus, that will become plus. So what will happen? You will get 5 2s are. So it's basically 5 by 8. So 4a has become 5 by 8. Now, in order to get the equation of the parabola, therefore the equation now becomes what? X squared equal to minus 4a, which is 5 minus 4a is 5 by 8. Alright, we have the 4a, it's only 4a which is 5 by 8, so it's minus 5 by 8 into y. I hope you have understood why, because there was a negative on both sides, so like that the 4a has become 5 by 8. So in this equation minus should be there, 4a we can replace by 5 by 8 and y. So that's how you are getting the equation of the parabola. But to find df, we have the coordinate. See, this is 2 over here. So the y coordinate is 2. We don't know the x coordinate, isn't it? So let f with coordinate k comma 2 be the point. Now this point is there on the parabola. F belongs to the parabola, right? So it satisfies the equation of the parabola. So what will happen? K squared equal to minus 5 by 8 into 2. Yeah, because that's how it is. So what happens? There is a problem. Okay, 2 is minus 2 because we are on the negative axis. So this is minus 2, right? So minus minus, they'll get cancelled. So it's k squared, which is 2 4s are 5 by 4, which makes k root 5 by 2 if you want, or plus or minus root 5 by 2, doesn't matter actually, because both sides, isn't it? So this is a positive side, so k is root 5 by 2. So what will happen? If k is root 5 by 2 means this distance df, this means that distance df is root 5 by 2. I hope you understand. This coordinate, we've got it as root 5 by 2. Meaning of this coordinate means x-axis distance. So that is this, right? So that is root 5 by 2. And this EF is a double of this because they are symmetric, right? So therefore EF is going to be the double of it. That is going to be 2 into root 5 by 2. That is root 5 itself. So that is what is the required width. So the required width, maybe you can write. Therefore the required width is root 5 meters, 2.23 whatever. That's how it will work. Otherwise you can leave it like this. So that's about our problem number 1 and 2, which was our part 1 video, and with the remaining application similarly we will be taking it up in the next video. Thank you.